Lesson number 4, harmful radiation. By the end of this lesson, you should be able to describe and explain the effects of radiation on living matter, and describe the importance of limiting exposure to radiation. When we absorb radiation, the amount received is the absorbed dose, measured in joules per kilogram. Ionizing radiations differ greatly in the way in which they affect biological materials. For example, alpha radiation causes much more harm than beta radiation for the same amount of energy. The unit which incorporates both the energy and the biological harm is the sievert, or SV, or the millisievert, which is 1/1000th of a sievert. It is known as the equivalent dose. Alpha, beta, and gamma radiations travel at high speeds, and alpha and beta are electrically charged. When these radiations enter your body, they can harm living cells. Low doses ionize the molecules which make up your cells. Thankfully, alpha radiation, which could cause the greatest amount of ionization, is large and not very penetrating. It is stopped by the outer layer of skin. If the dose is very high, so much energy is transferred that it can burn. Beta and gamma radiations are able to penetrate deep into the body. Even at low levels, the radiations can ionize DNA. This may cause the cells to grow and divide in an uncontrolled manner and become cancerous. If the ionization occurs in the DNA of the sperm or egg, then the result could be children born with birth defects. However, the body has systems which check the quality of DNA, and gametes with defective DNA are usually destroyed. On average, about half of all radiation comes from radon, a radioactive gas found particularly in areas with large amounts of granite and shale in the ground. Radon is the second largest cause of lung cancer after smoking. However, looking at the diagram, you are more likely to die from an accident indoors than from lung cancer caused by radon. Cosmic rays originate from outer space and collide with molecules in the atmosphere. At altitude, there are more cosmic rays because fewer of them have collided with air molecules. So the exposure of air crew and frequent flyers can be 100 to 300 times higher than the exposure at sea level. The average person in the UK receives 2.7 millisieverts of ionizing radiation a year. Nuclear workers receive 3.6 millisieverts, and air crew receive 4.6 millisieverts. These levels are still much lower than the European annual limit of 20 millisieverts set for a worker in a nuclear power plant. Research has shown that male pilots have slightly higher rates of several cancers compared with the national average. However, women seem to be at greater risk. Air hostesses have twice the risk of breast cancer compared to the average flyer. Nevertheless, statistics show that you are more likely to be healthy and safe in a plane than doing any other activities. So unless you are pregnant, you should not fly less or avoid cosmic rays.